Everybody, welcome to folks who are here in person, and welcome to everybody who's online joining us today too. We're so happy that you came out to join us. My name is Sarah Waddle. I'm the local extension educator here in Cook County. My office is right in the Cook County Community Center, just 2 blocks up the hill. If you haven't stopped by, welcome you to come by anytime. We're open weekdays, generally 8 to 4. And in addition to our work around natural resources, we also support the community around local food systems and agriculture, as well as families' health and well-being. So we have lots of resources to share from the University of Minnesota with all of us here in Cook County, and that's my job. So I'm so excited that Anna was able to come up today from Duluth and join us to share this exciting research and information with Cook County. And if you have questions following the presentation, she'll be fielding them. But beyond today, we're always here locally if you want to stop in and talk about what we presented today or have follow-up questions that can help connect with more information. So I will turn it over to Anna.
Great, thank you. So hi everyone, my name is Anna Stockstad. Let me restart this timer. All right, so I am an extension forester with U of M Extension. I work at the Cloquet Forestry Center and I live in Duluth. I just want to say thank you all so much for being here today, and also thank you to everyone on Zoom and for Sarah and Kelsey for hosting me today. I am always very happy to make the drive up here, especially on a beautiful day like today. And I'm really excited to be talking with you all about a new extension forestry project called Climate Ready Woodlands. And this is a project where we've released climate resilient and microfauna-friendly tree and plant lists for the entire state. And so this is actually the first workshop that we're doing for this new project. So I'm kind of testing out this curriculum, and we're going to be walking through the climate change basis for this project and what these tree and plant lists actually are and how you can implement them on your woodlands. And this was very much a collaborative project across the entire Extension Forestry team, with me, my colleague Angie, and Emily leading this project. So what are you going to be able to take away from today? You're first going to learn how is Minnesota's climate changing and what are the impacts on our forests? What are the ways that we can adapt our forests to the impacts of climate change looking forward into the future? What is the importance of microfauna? So thinking about pollinators, other insects, small mammals, and birds. What are the importance of those species when we think about rewilding? So creating resilient ecosystems of the future. We're going to walk through the methodology that we use to create these lists and why that's important. I'll share those tree and plant lists for this region in the Northeast Arrowhead. And I'm going to start off just by walking through how did we get here? Why did we think about making these lists in the first place? So we get a lot of questions about what trees do I plant, especially when I think about climate change. Especially small acreage landowners, these folks are really interested in using trees, the trees that they plant in order to help mitigate and adapt to the impacts of climate change. And we're calling this climate ready information because we want to be ready and proactive when we think about managing our forests for climate change. People are also really interested in creating pollinator-friendly habitats. Pollinators are important to all of us. They are the foundation of our ecosystems. And so we want to make sure that our woodlands and forest ecosystems support these pollinators. And of course, people are really always interested in thinking about the specific species to plant and what can do well on certain sites, especially when we add in this whole other big variable of climate change. And so this brought us to develop the Climate Ready Woodlands project. And we started this project by releasing the first iteration of our list on our blog earlier in the summer. And now we have a web page on the Extension website that I'll link to at the end of the presentation. But first, let's start thinking about how is the climate in Minnesota changing and what are the implications for our forests? So first of all, we know that Minnesota on average is getting warmer. The state's average temperature has been increasing since the early 1900s. And of course, we're going to have really cold winters and maybe pretty mild summers. But what's important is when we look at the trend across time, we can see that that temperature is overall increasing. The way that I like to think about climate versus weather is that weather is like the outfit that you put on a daily basis. You have to go into your closet and choose the outfit that you're going to wear every day. Meanwhile, climate, on the other hand, is your entire wardrobe, so the collection of those outfits, and that's what changes over time. So thinking more in the long term rather than in the short term. And so as a result, our hardiness zones are also shifting. We can see that zone 3 has shifted significantly northward since 1990, and even zone 5 has shifted here into the southern part of the state. So we can expect those hardiness zones to continue to shift as the climate warms. And so thinking about precipitation, Minnesota is on average getting more precipitation. So just like with the average temperature, we can see average precipitation increasing across time. And of course, with a lot of up and downs, but when we look at that average across time, it is increasing. But we are not consistently getting more rain throughout the year. Instead, as we've experienced this year, we are getting these large precipitation events separated by drought, which I'll go into a little bit more detail in the next slide. But when we look at these extreme precipitation events, we can see that the frequency of 1-inch rainfalls are becoming more common, more frequent. We have definitely experienced that this year with these big rainfall events. And this is an issue because when all that rain comes down at once, that increases erosion and that has a lot of impacts on our ecosystems. It causes flooding and the loss of soil from our ecosystems. So this keys us into that not only are our averages, like average precipitation and average temperature changing, but also the extremes are changing. And thinking about these extremes is important because those extremes define that threshold that tree species and wildlife species, for example, are adapted to. So again, we are also familiar with the idea that we are experiencing these longer periods of drought. And thinking about these droughts, separating these large precipitation events. So we're kind of oscillating between two different extremes of getting these large precipitation events and then periods of drought and bouncing back and forth between those. And so this figure is from the drought that occurred between 2020 and 2021. And we can see the issue here is that we already had a drought developing throughout 2020. And then there was rapid drought development on top of those drought conditions going into 2021. So these factors kind of stacking up on top of each other. And so then thinking seasonally and thinking about winter, our winters are starting to get warmer. Just like average temperature, the average winter temperature is increasing across time. And with those minimum winter temperatures, so the lows, those are increasing. And it's important to think about those low temperatures because those really cold temperatures help to control populations of species that we don't want in our ecosystems, like spruce budworm. Spruce budworm, it's killed off, a lot of populations can be killed off during the winter during really cold freezes. So those cold temperatures act as a control on some of those populations. So as those winter temperatures warm, that could mean fluctuations or different dynamics in species that we really don't want so much of, like spruce budworm. So we need to think about how that's going to impact our management going forward and how we can mitigate those impacts. So I just walked you through a lot of climate projections, which for me can feel pretty alarming and doesn't give me such a good feeling in my stomach to think about. But the good news is that we can take action when it comes to managing our forests for climate change. Forests are the best natural climate solution that we have, and we are very lucky to have so many forests here in Minnesota, especially privately owned woodlands here. So we can have an impact in how we manage our forests. So I'm going to walk you through some of the broad strategies that you can take when thinking about how to adapt your forests for climate change. So two words that we hear a lot in the world of climate change is mitigation versus adaptation, and I'm going to start off by defining these. So mitigation is the idea of trying to reduce the emissions that we're currently putting out and trying to stabilize the levels of those greenhouse gases, so like carbon dioxide and methane in the atmosphere. And in the forestry world, this would look like trying to maintain and increase the amount of carbon in our forests and forest products. So maybe we're letting our forests grow for longer before we do a harvest. We're harvesting more long-term wood products so that that carbon is stored in the long term, for example, in houses. Meanwhile, with adaptation, we're trying to adapt to climate change that has already occurred and is going to continue to occur. And in the forestry world, again, this looks like planting a diversity of tree species that are suited to a future climate. So we're adapting to that future climate. So mitigation and adaptation are both critically important. They're two sides of the same coin, and we need to take a tandem approach in order to be most successful in fighting climate change. But for the purpose of this project and the talk today, I'm really going to be focusing on adaptation and the idea of the fact that we have already committed to a certain amount of climate change, which we call committed warming. And this is because carbon dioxide lives for a very long time in the atmosphere, between 300 and 1,000 years. So all that carbon dioxide that we've already put into the atmosphere, unfortunately, it's not going anywhere. It's going to be there for a while. And the ocean has a lag time as it warms, about 25 to 50 years, which just means that it lags behind the atmospheric warming. So again, we need to worry about mitigating climate change by reducing our emissions, but we also need to think about adapting because we've already committed to a certain level of climate change. And we can use our forests not only to mitigate those impacts of climate change, because forests are really good at pulling carbon dioxide out of the atmosphere and storing it in their tissues as wood, but forests are also able to adapt and respond to the impacts of climate change, and we can use our management to help them adapt. So thinking about forest management, there is a spectrum of management approaches that we can take to help forests adapt to the impacts of climate change. And these strategies are resistance, resilience, and transition. Moving from the left side of the spectrum, where we're trying to reduce impacts and maintain our current conditions, all the way to the right, which is more forward-looking, and we're trying to intentionally facilitate change. So resistance, for example, would be if you want to maintain your current conditions. You want to preserve and protect what you have now. So you could create refugia, for example, white pine and white cedar on a north-facing slope, species that might not do as well in the future with climate change, but you want to protect those because that's what you value and care about the most. And in terms of risk is going to vary all across the spectrum. With resistance, when we think about the level of risk, so what is our risk of change when we're implementing these management strategies? With resistance, risk is going to increase over time because as the climate changes, you're going to have to put in more and more effort to maintain those current conditions. When we move to the right and look at resilience, resilience is where you accept some change in your ecosystem, but mainly you are looking to help that forest better respond and adapt to the impacts of a disturbance. So you want to make it able to bounce back after a disturbance such as a drought, or a large rainfall event, or heavy winter snowfall. You're just making it able to be more flexible and responsive to the impacts of climate change. And so what this would look like would just be promoting more diversity in your forest. For example, when I like to think about resilience and the idea of diversity, I think of spruce budworm impacts on our forests up here in the Northeast Arrowhead. A forest that is dominated by white spruce and balsam fir, both of which are hosts for spruce budworm, is not going to be very resilient when spruce budworm comes in and kills off the majority of those trees, because there's not any other species in there that will remain following the disturbance. Meanwhile, if we have a very diverse forest full of pines and hardwoods and then white spruce and balsam fir, if spruce budworm comes in and kills off the spruce and balsam, there is plenty of other species that can fill in those ecological spaces, and that forest will be resilient and able to respond afterwards. And so then when we think about risk with the concept of resilience, risk is just going to go up and down over time, because if a disturbance comes in, and if it's too much for that ecosystem to handle, then it's going to be at risk of change. And then moving all the way over to the right, forgot I had these little boxes. Moving all the way over to the right to transition. Again, this is where we want to intentionally facilitate change. This is the most forward-looking strategy that we can take. So what this would look like would be planting a diversity of tree species that we know will be suited to the future climate. And here, when we think about risk is going to be highest when we are first starting out, because we're planting species that are suited to a future climate, but not necessarily the present day's climate. And so for the purpose of this project, we are focused on the right side of the spectrum, thinking about resilience and transition. But just because this project is focused on the right side of the spectrum doesn't mean that resistance is a bad strategy. All three strategies are valid, and we are looking to implement all three in tandem. Just for these lists specifically, we were focused on the right side of the spectrum. When we look all the way over to the right side of the spectrum, on these lists, which is included on the handouts at the back of the room, we have included migration potential species. So these are species that are projected to perform well in a future climate here in Minnesota, but are not necessarily currently present in our forests. So all of these species are native to the broader eastern deciduous forest, which extends all the way into the eastern US, the southeastern US. It's this very broad ecosystem that covers pretty much the entire eastern part of the US. And all of these trees have a low risk of mortality from different pests and diseases. So we screened all the species that came up during our methodology. And if something had a major disease, for example, like butternut came up a lot on our list, but that suffers from butternut canker, unfortunately. So we removed that from the list. And on these lists, for this region specifically, sycamore is an example of one of those migration potential species. And this picture I'm showing here is actually a picture that my colleague Angie Gupta took down in Rochester. This is a sycamore naturally growing in a forest down there. And so when we think about the range of these species, they are likely to continue shifting northwards as the climate changes. And so this kind of brings up some food for thought. What do we consider a native species? So note that I'm not calling these migration potential species non-native. They are native to the broader eastern deciduous forest, but they're not necessarily present in Minnesota. And so just for some food for thought, I was at a national forestry conference last week and I went to a session on assisted migration, which is where you intentionally move species to where they will grow likely in a future climate, where they will be better suited to that future climate. And one of the talks focused on the idea of defining what is a native species. So historically, a native species that's been defined by its geographic location. But with climate change, where these species and their associated forest types are present, those are shifting because the environmental conditions of those geographic locations are shifting. So instead, we could have a mind frame shift where we are not thinking about native species only in terms of geographic location, but also thinking about native species in terms of their environmental conditions that they are best adapted to. So it's just something to think about here as we think about native species in the new era of climate change. So before I mentioned sycamore, and this is the current range of sycamore. You can see it has a very, very big range and extends into the northeast and down into the southeast. And as the climate changes, that range is going to continue to shift northwards. Like I said, it's already found in Rochester growing naturally, even though it necessarily isn't on this range map, but it is found growing naturally here in southeastern Minnesota. And we can expect that range to continue to shift northwards over time. But unfortunately, that also means that as these southern species shift northwards, the boreal forest is also going to be shifting northwards. There's a lot of work being done in Minnesota right now to research the impacts of climate change on the boreal forest, such as this project that's called Be Forewarned, or Boreal Forest Warming and an Ecotone in Danger, which is a very big name. But that's based at the Cloquet Forestry Center, and they are testing which species are going to be doing well in a future climate in the boreal forest. And this figure on the right is showing 4 different species that we can find in this region now. Balsam fir and white spruce are those iconic boreal species. And then we have red maple and sugar maple. As the summer temperature warms across time, we can see that the growth of balsam fir and white spruce declines. Meanwhile, red maple and sugar maple start to dominate as that climate warms. And personally, I want to make sure that our forests don't just become maple forests. When I'm out in the woods, I see a lot of red maple seedlings, and that can be concerning because, again, we want that diversity. We want a lot of diversity in our tree species, and we don't just want all maple. And managers here in the Northwoods, we are taking that 3-pronged approach of resistance, resilience, and transitions. We want to create strongholds of conifers, so our native pines and spruces and firs, but also increase diversity in our forests, maybe by promoting some other hardwood species in addition to maples. And we can start diversifying our northern forests on properties of all sizes using multiple different methods. But as I mentioned at the beginning of this presentation, we first released these lists on our blog through a series called Rewilding Your Backyard Woods, where we were targeting small acreage landowners who are looking to improve the resilience and diversity of their backyard woods. And rewilding is a concept similar to restoration. But restoration is the idea where you're trying to restore a past ecosystem. So something that's been lost and you're trying to bring it back into the present day. Meanwhile, rewilding, you're trying to create resilient, self-sustaining ecosystems of the future. So ecosystems that are adapted to the future. So we are focusing all of these lists on the idea of creating resilient, self-sustaining ecosystems that are going to be adapted to our future climate. Because again, we know that we have committed to a certain level of change, and so we need to try to help our forests adapt, because we want to have healthy and resilient forests going far into the future. And so we are focusing in on this idea of rewilding. And rewilding is really built on the concept of creating space for a diversity of not only tree and plant species, but also a diversity of these microfauna. So again, pollinators, other insects, birds, and small mammals. These species that make up the foundation of the ecosystem. Because when we have a strong foundation, at the bottom of this pyramid, the top of the pyramid is going to be even more strong. And so we want to have ecosystems that are resilient and diverse all the way from the bottom of the ecosystem all the way to the top. Because we know that biodiversity increases the resilience of an ecosystem. And so I'm talking a lot about all these different adaptation strategies and the idea of increasing resilience through increasing diversity. But where is this actually being done, and what type of work is going on beyond just our small extension forestry program? And so we know that over a third of forested land in Minnesota is privately owned, and a lot of landowners have climate resilience and biodiversity as one of their top objectives. But work is also being done through public agencies and land managed by Native nations here in the state and beyond. Because this idea of climate adaptation isn't new. The DNR, the Forest Service, tribes, and academics are all working to implement and evaluate that three-pronged approach of the different adaptation strategies. So looking at that spectrum from resistance to resilience to transition, and looking at how that performs actually on the landscape on large-scale experimental plantings. So for example, this adaptive silviculture for climate change project, this is implementing that spectrum of management approaches all across the country and in Canada as well, to see what are the success rates of those different adaptation approaches in many different forest types. And this document, if you're interested, this is a tribal climate adaptation menu. I can send this out to folks. It's a little bit of a longer document, but if you're interested, I can send you the PDF as well. And then Minnesota has the Minnesota's Climate Action Framework, which the DNR uses, and the Forest Service is doing a lot of work related to climate adaptation as well. Okay, so that was a lot of context and foundation, but I feel like all that foundation is really necessary in order to think broadly and understand these lists fully. So now let me tell you how we actually created these climate resilient, microfauna-friendly tree and plant lists for all the regions of the state. And I first want to emphasize that this is a model-based approach. So we use the results of climate models in order to make these lists. And so this is going to differ from some other lists that maybe use experimental data where we actually go out and plant trees. So just keep that in the back of your mind as I'm talking about these lists. So we combined two different data sources. We used ecological and climate modeling data from the DNR. And then we used climate modeling data from the Forest Service through the Northern Institute of Applied Climate Science. And what we did is we compiled all of the tree species from all of the native plant communities across the entire state, as well as the spotlighted plant species from those plant communities as well. Which, what that means is just, it's a lot of trees and a lot of plants that we analyzed all across the state. So it was a really big data set and it took a lot of work. And so we looked at each native plant community, compiled the species there. I'm going to jump through this a little bit. And then we compiled that data. And so we can see lots of data which had individual climate projections for every single species. We combined data from the Northern Institute of Applied Climate Science, which is a little bit blurry, so I apologize about that. But this is where we got those migration potential species from. So these are based off of climate models, and they modeled which species are predicted to do well in the future climate of this region in the Northeast Arrowhead. And so we combined those model results into one big data set, and we looked at every single species. And then for the plants, there isn't climate model data for plant species, so we had to think of a proxy. And so we just used the range of these different plant species to estimate their climate suitability. And so if a plant, if their current range extends far to the south and to the east, we could predict it to be resilient in a future climate. It's probably going to be here in 100 years. Unfortunately, this meant that a lot of the boreal species were not found to be climate resilient because they have a very limited range. And again, we're expecting that boreal forest to continue to shift northwards with climate change. And then we also looked at wildlife benefits. So for pollinators, insects, mammals, and birds, we documented all those different benefits for all the plant species and all the tree species. Again, because we're looking to promote that diversity of those wildlife species at the bottom of that ecological pyramid. So now let's finally get into what you've all been waiting for and actually talk about what these tree and plant lists are. And so, as I said, the name of this project is Climate Ready Woodlands, and we have released it on a new extension webpage at z.umn.edu/climate ready. There's also this QR code, and I'll be sending out these links after the class with the survey. And so we have 11 lists, the tree and plant list for all 11 ecoregions of the state. And we're all the way up here in Region 2, which is the Northern Superior Uplands. And before I actually talk about what these lists are, I do just want to mention that it's okay if these lists don't necessarily work for you. These lists are not intended to be the end-all, be-all list or the perfect list. It's totally okay if you don't feel comfortable with planting the migration potential species. But really, these lists are targeted towards folks if you want to improve the climate resilience of your woodland, and if you want to increase the biodiversity of your forested ecosystem. And those migration potential species specifically are right for you if you are interested in maybe being a little bit more experimental through small scale plantings to improve climate resilience. So we are not intending for you to plant a 30-acre clear cut full of these migration potential species or any one species on these lists. Instead, we want to improve the diversity of the trees that you're planting, and through small scale plantings, you could try out some of those migration potential species if you feel comfortable. So now we're going to start looking here at the list, and this is the first half of the tree list. And if you have the handout with the list, you can follow along there as well. So just let's look first at what are those Minnesota species on the list. Up at the top, we have box elder, silver maple, and yellow birch, all species that we can find in our woodlands. And then we have several different migration potential species, such as hickories, hackberry, and black walnut, which is a very valuable timber species and a valuable wildlife species. And what you're going to notice as I go through these lists is that you're not going to see any of our native pines, spruces, balsam fir on these lists. And when we did this analysis with our methodology, we found that those pines, spruces, those boreal species were not found to be climate resilient, unfortunately. So you're going to see a lot of hardwoods on these lists. And I've had someone say to me, well, I've been planting red pine for the last 30 years. Does that mean that I'm doing it wrong? No. If you care about red pine, if you value red pine or any other species that isn't on that list, it is totally valid to be planting that. Again, these lists are not meant to be the end-all, be-all list. These are just recommendations and one option for you to think about. And so again, lots of different hardwoods, and all these species on the migration potential list are very common just south of us, and some even in southern Minnesota. These are iconic species of the central hardwoods community, such as bitternut hickory and shagbark hickory, and really beautiful trees with lots of wildlife benefits. And we go into the second half of that tree list. We can see our native, or our Minnesota native species are ironwood, northern red oak, and American elm. And with American elm, remember I earlier mentioned we didn't include anything with any major disease concerns. If you're planting American elm, you want to make sure that you're planting Dutch elm disease resistant elm, which you can get through nurseries. And then northern red oak is looking like it's going to be very climate resilient, as well as some other oaks that we can't typically find up here, like white oak and swamp white oak and chinkapin oak, which is a more southern oak species. So again, lots of hardwoods, not a lot of conifers. The only conifer that made it on this list was eastern hemlock, which is an endangered species in Minnesota and has a very limited population. But with climate change, it's looking like it's going to be doing pretty well. So hopefully we can start to boost that population going forward into the future with climate change. Because hemlock is very common just to the east of us in the eastern states, but it's really very limited here in Minnesota. And so some of these trees are probably pretty wonky and weird sounding to you. They were very weird sounding to me when I was first working through these lists. And so when you're thinking about planting some of the trees off these lists, and really any forest management decision, you want to think about working with a forester or another natural resource professional, especially if you're thinking about planting some of those migration potential species. Because like I said earlier, when I was talking about risk and how that differs across that adaptation spectrum, with those migration potential species, risk is going to be highest when you're first planting them because you don't know if they're going to survive the next winter. They're adapted to a future climate, but not necessarily the one that we have right now. So you want to make sure that you're planting trees that are best suited to your site and that align with your goals and objectives for your own management. So as with anything, work with a forester. And if you're planting those migration potential species, thinking about doing it on a small scale where you can put more care and attention into those species. And now on the last page of your handout are our plant species. So these are understory plant species. And all of these are ones that are currently found in the region and are very, very common if you just walk out into the woods. So like bunchberry, large-leaf aster, Canada mayflower. These are things that are very, very common and they all provide wildlife benefits to many different species of pollinators and insects, birds, and small mammals. And these are things that you can get through nurseries to plant, or you can also just foster the growth of these understory species if they're already there in your forested ecosystem. And these are all going to have different shade tolerances and soil preferences. And so you can try your best to match those to your site. And again, working with a natural resource professional can help you to do that. And so as I alluded to earlier, these lists are just a single option in that wide spectrum of management approaches. And there really is no one way or no one right way to manage forests. It is all going to depend on your goals and objectives for your land. What do you want your forest to look like in the future? And what do you value and care about the most? We all have different perspectives when it comes to managing our land, and it's totally okay if these lists don't necessarily work for you. We are just offering a more forward-looking option, so far onto that transition side of the spectrum, the resilience and transition side of the spectrum. So this is just one option for you to consider. But as I start to wrap it up, one thing that I always like to mention during these talks is that as a woodland steward, the most important thing that you can do is just to keep your forest as a forest. It can get really scary when we start talking about all these changes that we can see with climate change in our forests. But just remember that the most important thing that you can do is to keep your forest as a forest. Because the biggest risk of carbon losses, which is what we want to avoid, that biggest risk comes from when we change a forest to something that isn't a forest. So changing a forest into a housing development, for example, we want to avoid that. So just by having a woodland, you are doing amazing things, and that's the most important thing that you can do. So now I'll start just to wrap it up with some key takeaways. So we know that Minnesota's climate is getting warmer, wetter, and experiencing changes in our extremes. So larger precipitation events, longer periods of drought, and warming low temperatures in the winter. The foundation of this entire project is the idea that a diverse ecosystem is a resilient ecosystem. So when we support the bottom parts of that foundation through tree and plant species diversity and diversity in our pollinators and insects, we are going to have a healthy, thriving ecosystem. To create these lists specifically, we took a model-based approach using combined data from the DNR and the U.S. Forest Service Northern Institute of Applied Climate Science. And there are tree and plant lists available for all the 11 ecoregions of the state available on our website, which I'll be pulling up again, or I'll be sending it out to you via email at the end of this workshop. And just one last slide thinking about what's next for this project. We are moving forward with doing some experimental plantings on the St. Paul campus and up in Grand Rapids as well. These are going to be experimental plantings mainly of those migration potential species so that we can measure how those species do and actually try to get some experimental data to back up our model-based approach. And then we are working to develop and implement statewide curriculum, which is what today is. This is the first time we are giving this talk, implementing this curriculum. And so in the survey that I'll be sending out after this workshop, I appreciate any feedback that you have for me. And then we are also looking, hopefully in the future, to do participatory science projects. So woodland stewards who plant these species, the goal is that they would be able to measure the success of those species and report back to us, especially for those migration potential species. Again, collecting that experimental data to back up the model-based approach and have folks involved in the science. And with that, I just want to again reiterate that this was a very collaborative project and that I thank all of my colleagues on the Extension Forestry team. We also had these lists in the methodology reviewed by folks at DNR Forestry and other natural resource professionals as well. So this has been a collaborative project beyond Extension as well. And with that, here's my contact info here in the middle, as well as the contact info for my colleagues involved in this project. Here's a QR code and a link to the survey, but I will be emailing this out to all of you. Feel free to email me at any time or give me a call if you ever have any questions or just want to talk more about this project. And I'm happy to answer any questions from you all here in the room as well as on Zoom. And thank you so much for listening.
So I have a question. I'm not sure I'm going to artfully word this, but what's the difference between a transition species and an invasive species? And specifically, what I was surprised by is, we see a lot of maple forest growing up here, and maples are pretty, but you implied that we don't want too many of those. Is that because they outcompete a lot of these and will threaten diversity? And if I live in I have 20 acres of land that is probably half maple forest. Am I supposed to treat those like invasive species, or am I supposed to find things that could outcompete them?
So really good question. And so my comment about maple is, and I apologize if I miscommunicated that, but it's really good at it's not an invasive species. It's just it's very good at just growing as a maple stand. And like I said, we want to have diverse forests. And so, for example, like if you walk through the woods, you can see just a lot of maple seedlings everywhere. And if the boreal forest starts to die back, the next thing coming in would be a lot of maple. And maple in itself is fine, but if it's all maple in a forest, that's not a very resilient ecosystem when it's just that one species or two species. Does that answer your question?
Yeah.
But I can also answer your question about like what is an invasive species?
Yeah.
And so like these transition species, they overlap in their ecological ranges with a lot of these understory species. They share similar environmental conditions. So like I said, rethinking how we think about native. But if we think about an invasive species such as European mountain ash, that was brought over from a totally different continent where it doesn't share any similar pollinators, it doesn't share similar environmental conditions. And so you're bringing it into a totally new ecosystem where it doesn't have any shared ecological associations. And so it's able to take over and dominate. Meanwhile, the transition species are from further south, but they are still part of this broader eastern deciduous forest, and they have a lot of those shared ecological associations. Does that make sense?
Yes.
Okay.
Thank you.
Yep.
So we have 2 questions in chat.
Okay.
What input is the forest product industry saying about the research project and plans?
That is a great question. We haven't gotten any targeted feedback from the forest products industry yet, but I can imagine that's a next step for us. Because one of our goals too is we're currently applying for federal grants, and part of that is to develop some forest management recommendations based on the idea that these southern species are going to be shifting northwards, and that has implications for our forest products industry. Because, for example, aspen, that wasn't on the list, but that is our top timber species. So what does that mean for the forest products industry in Minnesota? That means our markets are also going to be shifting in the future. So we'll have to work with foresters and forest products professionals farther down south in thinking about how we can, update management recommendations based on climate change projections and help our markets to shift.
Great. Next question is, what's a good way to find a forester to help with our property plan?
That's also a very good question. So if you Google DNR forester map, that'll bring up a list of DNR foresters. And in my follow-up email, I can send that link as well as a list of consulting foresters in this region who can help you out. You can always go to your local soil and water conservation district. A lot of the times they are a great first step. If you call their office, they can get you connected with a forester. So there are multiple different avenues. You can work with a DNR, SWC, find a consulting forester. So there are a few different methods as well. And I can send that information in my follow-up email.
Another question was, what are some suggestions for purchasing trees off this list or getting for free?
I forgot to print that handout. I had a handout on nurseries and I totally forgot to bring it, so I'll send that in my follow-up email. I have a list of nurseries in Minnesota and in Iowa and Wisconsin where you could purchase some of these trees. Some of these trees will be more difficult to get just because they are farther south. But part of this project is that we hope to encourage a shift in what's available at our nurseries, so promoting more climate adaptive trees at nurseries. But starting out, some of those trees may be difficult to get, but hopefully that changes with time.
I'm gonna do a quick follow-up,
Okay.
go on to you guys. With that being said, maybe Sarah, you might wanna kick into, there are seedlings that sometimes get given out in our community.
Yep.
Are those being, addressing that at all, or are some of those meeting some of the items on the list?
So I know
Like Soil and Water gives out, there's the Carolyn Dry.
I have looked at those and there are a lot of trees on that list. There are a lot of trees given out by the SWCD that are on our list, but there are several that aren't, for example, like white pine, red pine, spruces, things like that. But again, that doesn't mean you can't plant those. So just because the SWCD is selling those lists doesn't mean that you can't plant it just because it's not on these. And our goal is also to distribute these lists as well as like training curriculum to the SWCD so that they can hand out these lists during tree sales.
I can follow up to that too, to just add that the Soil and Water Conservation District gets the trees that they sell in the conservation tree sale from the Minnesota State Forest Nursery, which is run by the DNR, who's very connected to this research. So as they, learn more through experimental on the ground about these trees and how they do, I'm sure they'll be shifting the stock of what they're growing in the State Forest Nursery, which will trickle down to Soil and Water Conservation Districts changing what they're offering. But I wouldn't expect like in 2024, all of a sudden, there won't be these ones we're used to seeing and all these other ones. I think that would be a more gradual shift.
Absolutely.
I have a question on timing. When you talk about climate change, it sounds like it's a hard line, and I know it's a transitional thing.
Mm-hmm.
So was there any work done on your list as to which ones would be better to plant sooner? And which ones would happen in, say, 25, 50 years as climate changes?
That's a really good question, and we didn't really look into that. The time frame for the projections just went through 2100, and we didn't look at the dynamics of those transitions. But this is just the first iteration of these lists, and so I can imagine that we would start considering that in future iterations as we improve the methodology. We didn't look at that in this first round.
Thanks.
Yep.
So I have a bunch of questions, but
Okay.
I'll just ask them one at a time. Am I to assume from this tree in particular list that unless it says adaptable, probably they won't do well on red clay? Like I've been told that Ontonagon and red clay, pure,
Yep, and so, yeah, the trees that don't say adaptable or that they can tolerate clay specifically will probably have a tougher time in clay. And so that's the situation where I would definitely want to work with a forester to get specific advice on tree planting, because red clay specifically can make it a lot more difficult for some trees
Yeah, I
to
see
thrive.
well drained on.
Yeah, yeah.
I mean, the red clay has high fertility.
Yep, it's just not well drained.
It's not well drained,
Yeah.
okay, then I was surprised that I didn't see ponderosa pine on your list, because I remember reading in your little DNR magazine that it was very successful in Grand Rapids planting or somewhere in Minnesota.
Yep, so part of that, I mentioned the Adaptive Silviculture for Climate Change project. They have some plantings on the Chippewa National Forest where they have planted ponderosa, and I know that has done well. But like I said, we've only included trees that are native to that eastern deciduous forest, and ponderosa pine is a western tree species.
Well, it's in South Dakota.
Oh, it is. Oh, see.
Well, according to the article, I mean, and this surprised me because I didn't know, and I worked out west, and was a forester, but
Oh, wow. Okay.
I, yes, they said the closest, and it may have been like an eastern, how some species are eastern ponderosa,
Mhm.
as far east as South Dakota.
Yeah,
That's
those.
what they said.
Yeah, well, like those didn't show up on the models that we used. And so they never really came into consideration, unfortunately. Yep, on other regions of the state, but not this one, there were southeastern pine species, like pitch pine, came up, but no more western pines came up at all.
It's more from the south, not from the west.
So we were only looking east and south. We weren't looking west at all.
Okay,
Yep.
interesting.
I have two more questions for you. I have two. One is, out of the list of trees, is there cheaper ones on that list? That you would say, are cheaper ones?
So probably all the Minnesota species are gonna be cheaper and easier to get than those the migration potential species. But out of the migration potential species, I don't know the exact prices of them. I'll look into that and see what the general ranges are, because I'm assuming the farther that they have to come from, so if they're more like Missouri species, they're gonna be more expensive than a tree you could get in southern Minnesota and have shipped up, and so I think it's gonna vary. But I'll look into that and send any information in my follow-up email about prices specifically.
Wonderful, and then one that's just more of a statement. I grew up in eastern Ohio on the western edge of Allegheny Plateau. I can say that better than I'm sure. White pines were plentiful there, and thought that these trees would still be considered species that would do well here in northern Minnesota as the climate warms.
And so again, this is a model-based approach, and just white pine didn't show up based on our methodology, didn't show as climate resilient. But in practice, we'll see in 100 years how white pine is doing. It's still going to be here in 100 years. It just depends on what is that dominance of white pine actually going to be on the landscape. So none of these trees are going to just disappear in 100 years, or you don't have to chop them down or anything like that if they're not on the list. It just is thinking about their success rates and their dominance on the landscape as the climate transitions.
So some of these strategies seem like they'd be easier on a smaller property, but if you have a pretty large acreage, what's more important? Like with the plant part of it, is it getting rid of invasives or actively adding these? Because sometimes I just get so overwhelmed pulling tansies and lupin and trying to get, because I know those are invasive, but I don't know, is it more worth my time pulling invasives or actively planting new things like this?
I would say probably trying to manage for invasives as much as you can, because once you remove those invasives, they dominate ecosystems. So once you get those removed, I would say that those understory plant species would just naturally come in, through animals carrying in seeds and whatnot. They grow very well up here, but invasive species just crowd everything out. So that would be, I think that would be my priority, would be trying to manage for those, as hard as that is. I totally understand. So
You're a forester, so I don't want to put you on the spot, but you brought up lupins. I mean, has anybody noticed how they just, there's so many more. They're just, and then somebody wanted me to dig one up because it was in our septic mound. And I knew they were bad, but I'd never tried to dig one up before. The root system, and this it hadn't been there very long. I had to break off the root. I had it's just crazy. And how can you get rid of them? They're everywhere along Highway 7. They never used to be. They're just like, they were on 61 and now, they're just hideous. They're everywhere. What do we do?
I personally don't have any recommendations for eradicating lupin. My colleague Angie Gupta is the invasive species expert on our team, so I can ask her and send that in my follow-up email, because she'll be able to give a much better answer than I can.
Okay.
So
we were told, just don't let them seed for like 3 years in a row. Just
Cut the seeds.
just get them,
Cut them before they can see.
cut them
It's
away.
Cut them before they can see.
Yeah, and I've been doing, I don't have it, well, I see one of my place when they die, but I've done that on other places, like friends or relatives, I take my sickle and cut the seeds back, but boy, where I worked, it didn't seem to work. I cut them back every year. Then they said spray them. I tried that didn't work, and they're just really, or maybe I missed one, but yeah, the seed is. It's just.
I can add on a little bit to the lupin conversation. I participate in the Cook County Invasives team, which is a bunch of agencies and groups concerned about invasive species in the county who get together. And lupin came up at the most recent meeting, and it was just noted how controversial of a species it is, because so many people see it as a beautiful flower and try to plant it, that it's really difficult to work towards eradication. When it's, sold in all the garden stores and people are sharing it with each other. So it was just, there wasn't a resolution or a specific recommendation, but many of the participating agencies just sort of shared a feeling that that's a particularly difficult invasive to talk about because people have such charged opinions about it.
Well, and just to add on to that, I grew up in New England where it isn't considered invasive. It's everywhere. It's considered beautiful, it's all over Vermont, New
Yeah.
Hampshire. And so when I first came here, I was like, whoa, yippee skippy, I'm gonna plant some lupin because I love lupin and it makes me feel like I'm at home. And then I ran into a neighbor who was Forest Service who gave me the stink eye. And I said, what are you doing? And I felt terrible. But anyway, the point is, I think, a lot of it is where you're from and what you're used to seeing. And
Well-
I now am more educated and I realize that it's killing things that
But it
shouldn't
is
be.
native, in many places, there's no blue.
Right.
So maybe you could explain why, why is it so bad? What is it displacing here?
Right, I think that would be helpful if people understood
Yeah,
what
they
it's
understood.
displacing because, maybe it's truly gonna be more like a transition plan
Right.
because in New England, it's everywhere.
You
And
can't,
Yeah.
get a joint, with
Yeah.
that. That's what I thought too.
I'd like to bring it back to some trees.
Yes.
One of the ways on this list, we have 80 acres up at Woodlands, and it's fully forested, it's wonderful. We are seeing some change, of course, with spruce budworms and things like that. So we have some black ash. So if I go on and find out the type of soil types that black ash grows in, then I take that information and come back to your list here to see what might be planted similarly to that. Would that be a strategy that a property owner could use?
Yep, so yeah, looking at what your site conditions are, especially soil conditions, and trying to
Right.
map that up with, match that up with species on the list to help determine what you want to plant. Swamp white oak can be a good replacement for black ash,
Okay,
and that's on these lists. And you'll also note that there are no ash trees on any of the lists,
all right.
but in the models, they actually did really, really well, including black ash. But because of emerald ash borer, we had to take them off, which was
Mhm.
really sad because green ash and black ash did really well, but.
Okay. And then the same, we have, we also have a bunch of beaked hazelnut, where the beavers have chewed down the overstory, and what's come back is a lot of beaked hazelnut. So we could look at that, that's what's on here, and then find some tree that would go in that needed full sun to reestablish the overstory.
Yep,
Okay.
yeah, so if you have a lot of beaked hazelnut and it's already there and you're not gonna be removing it, you could think about shade tolerant species, so trees that tolerate shade. But if you wanna get rid of that beaked hazelnut and go in and plant trees that need full sun, you can look for those full sun species on.
Yeah, I was thinking about mowing certain parts of it to open up the sun for
Yep.
full sun trees.
Yep, and so in those gaps, you could go in and plant those trees that really prefer full sun, and they would do pretty well, I would imagine.
And what about these hardwoods in terms of deer eating them? We know with the evergreens that you gotta fence it. Would you have to
Yeah.
fence these also?
So the oaks, I would say, you'd probably wanna fence it.
Okay,
The deer do really like red oak, which is on the list, and I can imagine the other oak species as well. So I would recommend fencing,
Okay.
whether those are, whether you do bud capping, or just maybe larger fencing would be a good idea. But for the oaks especially, I think that would be wise.
what about the trunks? We lost all of our 4 fruit trees this last year because I didn't think to put, it was my own fault, I didn't put any trunk protectors on it. And first winter, there was no problem. This last winter, it killed all 4 of them.
I've heard
Same thing.
I've heard the same thing, that last winter people had a lot of problems with voles, and so I think just out of caution, I would do that as much as you can, try to protect the trunks.
Okay.
Yep.
Thank you.